Okay, now let's create the iterator. All right, there's our iterator method stub that we have to return an iterator that holds objects of type E. Okay, and this is actually going to be very easy, this particular method, because all we're going to do here is we are going to return a new StackIterator. Okay, so that's the easy part. We have to return this new StackIterator, but as you can see, StackIterator cannot be resolved to a type. That means, what the heck is a StackIterator? Well, we have to create a StackIterator object. And to do that, we're going to create an inner class. I'm going to make that inner class private. Okay, private class, and its name is StackIterator. And StackIterator extends iterator. And specifically, it extends iterator with type E. Okay, so I'm sorry. Okay, so type StackIterator implements. All right, my bad. And that's much better. Okay, now it says it must implement the inherited abstract methods. Okay, so that's cool. So we just click here and we just say add unimplemented methods. And there are method stubs for our unimplemented methods. Okay, so we have this has next and we have this next. And let me just remind you up here that here's how you use an iterator. You basically say while iterator has next, you assign, okay, you assign the next element to something. Iterator next. And then you basically use elements somehow. Okay, and close off the while loop. So that's the standard form for using an iterator. You call this, you check if there's a next element. If there is a next element, you assign that next element to a variable, and then you use that. Okay, one thing you should know is that when you are using an iterator element, this assignment basically, when you make this assignment, you're not doing a deep copy of the element, you're just getting a handle to that element. Okay, and a handle is a reference in Java. So, you know, basically you've got an object on the stack and you've got two different references to it. But you're basically copying the reference. All right. So this is what we tend to call a shallow copy. So that's just FYI. The point is we're not doing any kind of deep copy. You don't have to have a specific copy operation in order to create an iterator. You just get a handle to the element, and then you somehow use the element. And the idea is that you want to use this element. Well, you don't have to, but it probably saves you a lot of hassle if you just use this element in a read-only way. Okay, just kind of like you're accessing the element. The reason for that, another reason for that is, in general, you don't want the iterator to modify your existing collection. So we've got a stack, a bounded stack. We've got it laid out the way we want it laid out, and we don't want to mess with it. Okay, we don't want to mess with the stack as it is. But we might want to iterate through the elements of that stack in order to print them. or in order to check if they're equal to some other stack elements. All right, so we're just getting access to them. We can modify them, but once you start modifying elements, you can get into trouble. All right, so avoid it if you can. Avoid modifying iterated elements if you can. Okay, so now that we've seen how to use a StackIterator, let me remind you of what our stack looks like, or let me give you an example. So here's the representation, or let me give you an example representation of a stack. Okay, our elements array might equal, you know, A, B, C, D, E, F. Okay, and the depth equals 3, and capacity equals 6. And actually, if you look at the abstraction function, you should kind of know what the abstract representation of the stack will be. The abstraction is going to be A, B, C, colon 6. And why is that? Because the array is holding our stack elements, but because the depth of the stack is only 3, we only care about the first 3 elements. Only the first 3 elements are relevant to our stack. This DEF, those are basically irrelevant. Okay, so these last 3 elements could essentially be anything. Okay, or they could even be null values, and it wouldn't matter. All right, our stack is still going to look like this. Okay, now one last thing before we actually start implementing this iterator, which I promise we will do that, is that we want to iterate through the elements from bottom to top. Okay, so we want to start with the bottom element, and we want to end with the top element. Okay, so that's how we're going to iterate through this stack. Now, doing that is not that difficult, actually, okay? Because we know that A is the bottom element, then comes B, and finally C is the top element. Okay, so all we really have to do is the first time we call next, we want to return A, the bottom element. The second time we call next, we're going to return B. And the last time we call next, well, the third time we call next, we're going to return C. And hopefully, because if you look at this loop up there, you know, you will check if there is a next element. Okay, so if there is no next element, you're not going to call next again. All right, so this is the typical, again, this is the typical format, the way you use an iterator. It's important to remember that we're not going to change the stack. We're not going to modify the stack. In fact, we're not even going to modify the underlying array. We're not going to modify the array. We're not going to modify depth. We're not going to modify capacity. We're not going to modify anything while we're iterating through this stack. Okay, we're just going to iterate through it, get a reference to the first element, and then get a reference to the next element, and finally get a reference to the top element. All right, so how do we do that? Well, we have an array. Okay, that's our representation. That's part of our representation. All we need to do is set up a temporary index to the elements of this array. So initially our index will be 0, and then we'll return elements of 0. Then our index will be 1, we'll increment it, then we'll return elements of 1, and finally our increment our index will be 2, and we'll return elements of 2. So that's how we're going to do that. And in order to do that, we need to create a private variable here. I'll just call it index. Okay. And now I've got an index, and I've got my 2 methods here, but I want to have a constructor. All right. So the constructor is going to be public StackIterator, and it's got to take something. No, it takes no arguments, but it's got to have the parentheses. And all I'm going to do here is I'm going to set my index to be 0. All right. So I'm setting my index to be 0 because the first element I want to return is the 0th element in the array. So let's implement these in turn. HasNext just checks if there's a next element. Well, you can do that by figuring out the value of index. For example, in this stack with 3 elements, if the value of index is 0, then yes, there's still a next element. It's this elements of 0. If the value of index is 1, there's still a next element. If the value of index is 2, there's still a next element. But if the value of index is 3, there is no next element. Okay, because the depth of the stack is 3. And since the array indices start from 0, all you need to do is return the result of index if it has a next element if index is strictly less than depth. Okay. All right, so that was pretty easy. Now we'll just do the next. And usually when I'm, this is kind of like the pop operation. When I'm returning something, I usually put a result there because I might have to do things after I access that element. And it turns out that here I'm going to have to do things also. So I'm going to access index. Okay, but I also have to increment index. Okay, so I'm going to say index equals index plus 1. And then I'm going to return result. But there's one last thing I have to do here. And that is with this next operation. Typically you should call an iterator by checking if something has a next before you call the next operation, obviously. But you can't force people to do that. So if somebody inadvertently calls next when there is no next element, you have to respond to that. And the way you do that is you simply say if there is no next element, then throw new no such element exception. Okay, and that's just the exception that you throw in this case. We go here, it cannot be resolved to a type, but we can just import it. And it's done. And you can see that this error over here that we had with StackIterator is now gone because we have the constructor and we have the StackIterator.